Go. Cool. So we'll do a bit of revision first. So, what are two types of gas discharge lamps, and where might you normally see them? Two types of gas discharge lamps. Where might you see them? Let's bring my computer up. Halogen, metal halide, yep. Grow rooms, yes. Gas discharge lighting is very good for grow ops because it does put out quite a bit of heat. Fluorescent in an office, yep. Some raw meat sitting on a desk. Yeah, fluorescent lamps, you typically see them in offices, some old, outdated school infrastructure. The fact that you know that, Troy. Cool. Cool. Fluoro lamps offer soft white lighting, but they're not good because of their stroboscopic effect. High pressure sodium used in street lights and warehouses. They give out that warm orange glow. Cool. So what is the stroboscopic effect? Anyone tell me what the stroboscopic effect is? It's okay, yeah. Yep, can make moving machinery look like it's still because the strobing is happening at the same frequency as the power supply, and that is what determines the speed of the motor. So if the motor is also spinning at the same frequency of the supply, and the flicker is the same as the supply, the machine can appear to be stationary. What other kind of effects does it have, the fluorescent lighting flicker? The reason why they're starting to take them out of schools now. Yeah, terrible for recording with cameras. What else? Headache, yeah. So the flicker, yeah, caused eye strain and gave people a headache. It wasn't quite bad enough for epilepsy, but it did give a lot of people headaches. Cool. So why are incandescent lamps becoming less common in modern installations? Yeah, shit, terrible energy rating, not efficient, effective. Yeah, so basically they're energy inefficient. They convert more energy to heat rather than light. They have a shorter lifespan compared to newer technologies like LED and gas discharge. Then energy efficiency regulations have led to them being largely phased out. You can still buy them, but they are hard to come by. Cool. So, when planning lighting layout, what considerations would you have regarding beam angles of luminaires? Uh, Light throw is good. Not when so when we're talking about beam angle, we're not kind of worried about what's going on in the room or the purpose of the room. Yeah. Cool. So your narrow beam angles, so they're focused for spotlight effects. They're useful in task lighting scenarios. So when we talk about task lighting, it means lighting provided for a task to be completed. So whether that's cutting on a bench top, working at a woodworking bench, or a study desk where you're reading and doing kind of intricate work. And then you got your wide beam angles. These provide softer, more widespread illumination. They're ideal for ambient lighting. So beam angle combined with mounting height significantly affects the lighting coverage and should match the purpose of the room. So yeah, purpose of the room does take into effect. Cool. So describe one key installation requirement for recessed luminaires according to ASNZS 3000. You guys should all know this one. It's a question in the assessment for this unit. Yep, the sticker at the manhole. What does the sticker at the manhole need to say? Don't give me the whole thing. Just give me at least a brief overview of it. We're good, whoever. We're just doing some revision. Cool. Do not cover the light fittings with thermal insulation. Yep. Basically it. Cool. So basically it says, warning, recessed lights being installed in roof space to reduce risk of fire. Do not cover the light fittings with thermal insulation or any other material unless in accordance with instructions provided by the light fitting or barrier manufacturer. So basically it should say, do not cover these lights. Cool. So be honest, I'm making my life easier because yeah, most of those questions I have to manually mark. So you guys didn't realize a lot of the assessment for the unit we just finished is manually marked. So please bear with me when it comes to doing the manual marking. Yeah. End of the day, I want to make sure you guys have the information to pass the assessment. Sometimes it's a bit hard to find. If you don't get the question right the first time, please go back and read the material. If the second time it's still not right, email me. I will point you in a direction where you should look for the information. And then, yeah, well, the idea is not to do more than 3 attempts because it's hard. Cool. So, what is the wiring system? What do you think a wiring system is? So if I say wiring system, yeah, system that holds and protects the wires, yeah. Anyone got anything else? I want everyone to give me at least one answer for this. What is a wiring enclosure? Sorry, a wiring system. System. The interesting one, system that transports electricity. Something that will hold the cables in place. Yeah. Way to keep wires tidy and out of the way. Well, remember, guys, that best way for me to mark the attendance for night classes for you guys to put stuff into the group chat. This way I can just look up your name. Cool. He or she posted at least 4 or 5 times. Yep, they were definitely paying attention. Tick. Yeah. Fair enough. That's why I record everything and put it on YouTube. So that way you guys can watch it again when you get less brain fog. Well, hey, look at it this way. You guys are going to get a early school holiday break after next week. So, yeah. Cool. So, basically, a wiring system is everything needed to get electricity from A to B. Everything needed to get electricity from A to B. So it includes all the cable supports and enclosures up to the connection point of a load, but not the load itself. Cool. So why might you need conduit when installing TPS in a wall cavity? When would you need additional protection? Yep, solar's one. Polystyrene, yep. Internal sliding doors, close to the surface of the stud. Any word callers? Yep. Electromechanical protection through steel beams. So you've got to run conduit wire. Has anyone come across steel conduit inside old houses? Concrete wall, yep. You say dodgy, but when they installed it, it complied. You don't have to rip it out as long as the conduit is continuous. So this is similar to what the Americans do in commercial over in the United States. They use steel conduit for the runs and run conduit wire. Basically the conduit acts as the earthing system. It is quite dangerous because it means that the conduit can become live if it's not earthed properly. Because what a lot of people used to do is yeah, conduit is the earth. Yeah, that was the way they ran the earth, is that the idea was the steel conduit was continuous and it was a thick enough gauge that it would still be good enough to trip the circuit protection, but obviously people over the years have cut into it, joined into it with plastic, and so the earth is not always continuous. If they've been a good Sparky, they will have used two earth clamps to put a little jumper between, which is one way you can get around it. It's the same if you cut and join a piece of copper pipe with butylene piping. You have to put a earth clamp on either side and run a bonding wire between the two. I actually found that at my aunt's house over the weekend. They had cut a bit of copper into a copper line about this much, but unfortunately when they did it, everyone was using Ducks Quest. So there is a short little section of Ducks Quest between the two copper pipes, which means there's a quite bad failure point. If anyone has heard of or you've seen Ducks Quest piping before, it's basically not if it's going to leak, but when. So let's look at some wiring systems. Cool. So steel conduit. So this is in America, just based on the way they've done the conduit. But as you can see, it can look quite nice. A lot of time and effort gets put into making the steel conduit look nice. When might we use steel conduit here in New Zealand? Other than old residential houses, where do you think steel conduit might be used? Industrial, yeah. Not so much hot situations. We'd probably use MIMS cable first. Chemical, definitely, yeah. Underground parking, you could use steel, but most of the time you could get away with PVC. There is one really good thing about steel conduit, and what is it? Versus PVC. Strength and mechanical stress. So steel conduit can take a lot more of an impact. So we can install it in a location where it's likely to be exposed to high velocity or high velocity impact or basically high force impact. So the one time I've done it in a residential situation was down a driveway. So we weren't allowed to dig up the driveway. Yep, it would be used in the mines. Yep. Yep, so I installed it down the side of a driveway that wouldn't let us dig up, but we had to upgrade the mains from single phase 16 mil to 3-phase 16 mil. So we ran steel conduit down the length of the driveway. It was about, I could say 30, 40 meters of steel conduit. And then we ducked underground for a little bit and came back up into the house. So yeah, one thing you have to remember though with steel conduit, if you run a live cable inside of it, you need to bond it just like any other exposed metal wiring container. Enough about steel conduit. If you guys do industrial or go over to the mines, you will come across it. But if you're just doing general commercial and commercial and residential, it's less likely that you're going to come across it. But it is still possible. Cool. So PVC conduit, what's the difference between the top and the bottom? Color, yeah. What is the color significant? Yeah. Top is underground, yeah. Male, female, no. All right, yeah. Orange is for underground, Orange can be chemically rated, but that's more about wires. Yeah, so generally we use orange as we consider it ducting for underground, and white or gray or very other many colors are for above ground. But we need to make sure if we're using it outside, we make sure that it's UV stabilized so it does not wear out under UV light. Then you've got your various different types of connections, and you've got saddles and conduit clips there. So we need to make sure we're using the correct type of fitting. You can see two junction boxes there on the left. One is normal and one is a raised one. The raised one is for when you need extra space or you're running in a concrete slab and it needs to pop up. Cool, and this is your corrugated or flexible conduit. It's very good for running around those tight and strange kind of corners and angles. There are some guys out there who just exclusively use flexible. They don't even bother with rigid or solid conduit. They just run everything in flexible. And it looks like absolute dog shite. Yeah. I would rather use straight runs where I can and bends. Yes, it does degrade faster and it is more susceptible to mechanical damage. What else? But yeah, has anyone done much or any conduit bending with a bending spring? Good to see some people out there are still, you've seen it. If your tradesman's got a spring, see if he can give you an offcut of 25. Wasted a few meters on it. Yep. Yeah, so it is something that it is becoming a little bit of a lost art for some people, but being able to bend conduit is still quite a useful skill. For a few minutes, your tradesman took back over. Hey, you've got to learn somehow. You know, that's the thing. You guys are apprentices. You're learning. And some of these skills take time to master. It used to be part of trade cert was bending conduit. It's since been taken out, but it used to be a major part. Again, still before my time, but I still hear about it from Paul. Cool. Trunking. Who does a lot of trunking work? Or capping, as some people like to call it. The heat pumps, yeah. So the messages on the screen, what are going on? In offices, yeah, when it's 4 p.m. Yeah, so one unfortunate thing of my apprenticeship, because I did Housing New Zealand work, carried up 10 floors like that. When I did Housing New Zealand work, when we first started, they would not let us cut holes and patches. So sometimes when we had downstairs, upstairs split units, the downstairs flat would have its stove upgraded from gas to electric, which means I had to run a 6mm twin and earth cable to the stove location from the switchboard. And sometimes that switchboard was in the hallway, so I'd have to come down the hallway, through the kitchen, along the full length of the kitchen and around the corner, and then down to the stove. So one job, the worst one I had to do, I had to run, I think I went through a 10-pack of capping to run to the stove. The switchboard was that far away. And I couldn't run it through the ceiling because I wasn't allowed to make holes because we weren't allowed to do patches. Yeah. You can get some really good capping jobs out there, and sometimes you get some really bad ones. Cool. So this is your capping or trunking for inside of your industrial control boards. So it's got little fingers so you can get, with gaps so you can get the wires out to your control devices. So mostly you will see this in switchboards, sometimes in offices. And then this is your steel box trunking, or sometimes it comes in stainless steel or aluminium. And so this is what you kind of run around the edge of the office to run your PowerPoints. So you're carrying the plastic stuff, it's not too bad. You're carrying the heavy gauge steel stuff, it gets old real quick. Cool. What is the main thing in this picture? What is it? I want you guys to see, I want to see if you guys can, it's cable. What is the cable sitting on? I expect you to know better, Andy. Cable tray, cable tray. There we go. Fergus got it. Cable ladder or ladder rack. So this is what we call cable ladder. It is not the same as cable tray. So cable ladder is used more for your big cables. As you can see, there's less material, so it's more cost effective. It's usually used for your big mains runs down through the main trunking of the building. So you'll find this coming out of switchboard rooms or running inside of big, massive main switchboard rooms. So this would be the stuff going through the basement to the fire riser and then up to the fire riser, bringing the mains to each floor. And then this is your cable tray. So it comes in varying widths. What considerations might we need to worry about when we're installing things like cable ladder and cable tray? Cable burn, earthing, yep. Bonding, the weight of the cables, yep. Brackets, the distance, yep. So having, so generally you don't want more than, I don't know, Andy, how far apart do we run the uni strut for the hospital? Ventilation, yeah. Heat between the cables being close together, yeah. The magnetic effects, what kind of cables are going to run on the cable? Is it going to have both data and power? You don't want your ports to be too far apart. Most of the time, you're doing a big enough job, you'll be told how far apart you have them. But you generally don't want to be about 1.5 to 2 meters, any more than that, especially if it's got a lot of cables on it. But what about environmental factors? What kind of environmental factors other than heat and ventilation do we need to worry about? Other services, yep. Rust and corrosion, yep. So do we need it to be, can it be plain steel? Does it need to be galvanized? Does it need to be stainless steel? That kind of thing. What kind of fasteners are we going to use? Is it going to be dynabolted into the ceiling with joiners, or are we going to be putting threaded rod through something else? Do we need to do seismic bracing? So any drop over 400 mil, we need to do seismic bracing. Or at least that's what it was at the hospital, I believe. There is a certain requirement for mechanical. But yeah, if the threaded rod coming down from the ceiling is too long, you need to brace it. And then you'll also need to do seismic strapping as per the engineer's drawings. And this is cable basket. So what do we use cable basket for? Yeah, data security, cables that do not need as much support. So generally, the data cables go in here because they can just lie on top of each other and it doesn't matter because they don't generate as much heat. So we don't need to worry about heat dissipation or overcrowding. Usually, because the Sparkies are installing the cable tray, they usually end up doing the basket as well. Sometimes you'll just have one trade or one builder who's doing all of the cable tray and basket. But more oftentimes than not, it usually ends up being the electrical companies that install both the cable tray and basket for a job. And if you're a Welsh guy named Dave, you usually end up doing all of it. Cool. Just a better shot of the underside of the Unistrut for the cable tray. I'm not 100% sure what kind of hanging system they're using there, but usually we would be using threaded rod with bolts, nut and bolts. Cool. Catenary hanging systems. So what do we need to be aware of with catenary systems? Weight? Yep, definitely. Yep, amount of cables heading up at the cables, the weights, yep. Where to mount the cable. Fixings at either end, yep, the span. Yep, we don't want to have too long of a span because we will get droops. So we generally want to make sure we're supporting the cable every, at least every 5 or so meters. Again, depending on the weight of the cables. And that weight of the cables will then determine how many cables you can put on it. So if you've got a 3-core and earth 25 mil cable, how many cables, you've got 3 of them to run, how many catenary wires are you running? Magnetic conduction yet? So if I've got 3 25 mil 4-core and earth cables to run, how many catenary wires? 1 for each, yeah? Any advances on that? Three cat wires. Yeah, so I'd be going 3 cat wires minimum. Sometimes you might even double up on the catenary wires and have 2 cat wires per cable. Or the better answer, how about we just run some cable tray? Because yeah, catenary wire is not the greatest for things like that, unless you have no other choice, in which case that's just the way you got to do it. So what is the most common place day to day you will see catenary wire systems? Actually, no. I stand corrected. If you're in anywhere in central Wellington, house to sheds, yeah. Sorry. My bad. I forget. I live in Wellington. You guys not all do. Railway lines. Yeah, that's where you guys will mostly see them. But the everyday person will more likely see them on the rail yards or on the railways. They are used quite extensively throughout the electrified rail network for overhead. Yeah. What can you never use your catenary wire to do? There's one thing you can 100% never use your catenary wire for. In certain situations, you can use it as an earth. Hang off it with a harness. Yep. But yeah, you cannot use it as an active conductor. It has not got the required insulation to be an active conductor. Obviously, we do have uninsulated live conductors out there in the world, but they are so far off the ground that we can't touch them. Cool. Who can tell me what these are? Yeah, they are a cable dropper. So these are most commonly found in office buildings. They are usually used for dropping data and power cables down to a set of desks in an office. Usually they're not quite that colorful. They're normally white or black, but obviously this office space has decided to go for a nice funky green color. But yeah, they're used for dropping cables from the ceiling grid, down to a set of desks. Otherwise, we would obviously have to run it through the floor and then up. So this is a good way of getting cables to a set of desks that are out in the middle of the office space. What is this? We got So it is a trailing cable or trailing rack. Yeah, it's track for moving cables, but it is a trailing cable. So basically, it is a cable for a machine that trails behind it. So you'll see machines that have fixed wires and their trailing leads to allow them to move, especially like this, and do a task. So they won't always have this hardcore plastic or metal kind of trunking, but it is there. That is there for mechanical protection. So it is a lead that is connected to a machine that can flex and move while the machine performs its task. So one of the more impressive ones you might see in the news is the new fully electric digger that they've got working in one of the mines up north. That cable is probably about yay round for one conductor. It's massive. Cool. So now that we have this information, what other information do we need to install these safely? Yep. Lots of apprentices do it for me. Yeah. So the main thing we need is regs. We need to know the requirements to install these safely. Cool. So we need to look at AS/NZS 3000 2007, section 4. Oh, that's the wrong one. There we go. Cool. Section 3, selection and installation of wiring systems. So, cool. So, we need to worry about section 3 for wiring systems. Cool. Selection and installation. So, wiring systems shall be selected and installed to perform the following functions associated with the safe design and construction and proper operation of the electrical installation. So they'll be selected and installed to basically do all the functions to make it safe and operate properly. Am I wrong there? Cool. So protect against physical contact with live parts by durable insulation materials or by placing live parts out of reach. Cool. Satisfy current carrying capacity, so that's cable size, volt drop, and other minimum size requirements. We must provide reliability and electrical continuity of connections. So we need to make sure our joints and terminations are going to stand up to the test of time and be reliable. So no twist and tape and no use of solder. Why do we not use solder anymore in general electrical work? Solder breaks, less mechanical strength and crimps. What else? What's the beauty of lead or non-lead based solder? What property makes it really easy to use? Melts easily. Yep, it has a very low melting point. So if we have it anywhere where there might be a high temp joint or where we might be passing a lot of current through cables, that solder can melt, and then the cables that we've joined together might just ping apart. So provide adequate strength and supports, suspensions, and fixings. So we need to make sure that our supports are strong and that they're not flimsy, and they're very good suspension systems. They need to be suitable for the intended use, including requiring a particular type of wiring system, so fire resistant and explosive protection. So depending on whether we use PVC or steel, might be dependent on whether we have to survive an explosion or other things. So protect against mechanical damage. So if we know there's going to be a high likelihood of mechanical damage or mechanical impact, we need to use a stronger wiring enclosure for this. So 3.4.4, coordination between conductors and protective device. So the current rating of the breaker shall not be greater than the cable current capacity, and the rating of the HRC fuse shall not be greater than 90% of the cable current carrying capacity. Why does the HRC fuse not be greater than 90% of the cable current capacity? Why might this be the case? Yeah. Yeah, because of the HRC's trip characteristics and it taking too long to operate, that the current will be sustained for such a long period that it will cause more damage. Cool. So nominal cross-sectional area of a conductor shall not be less than the values given in table 3.3. Cool. So insulated conductors for socket outlets, copper cross-sectional area shall not be less than 2.5. Other circuits may be 1. Signal and relay control circuits may be as small as 0.5. So any bare copper conductors cannot be less than 6 mil. The minimal cross-sectional area of flexible conductors can be 0.75. Aerial wiring, copper 6, aluminium 16. So these are minimums. There is an exception for socket outlets, but we won't get into that. Cool. Minimum size of the neutral conductor. So it should not be less than that of the current carrying capacity of the largest associated active conductor. So if we have a 25 mil phase, we must have a 25 mil neutral. Even if only, for example, we've got 3 phases running to a property, one of them is 25, 2 of them are 16, our neutral conductor must be 25 because it must match the current carrying capacity of the largest associated active conductor. Cool. So we must make sure that we have a sufficient cross-sectional area so that the electrical installation does not exceed 5% of the nominal voltage at the point of supply. So that's for volt drop. So we cannot allow more than 5% volt drop at any point in the supply, at any point in the installation, versus the voltage at the point of supply. That's why sometimes we increase the size of the conductor, even though we're not carrying much current. Over such a distance, we're going to get volt drop. You guys will learn a lot more about this in year 3. Cool. So, wiring systems likely to be disturbed. So, installed in the following locations are deemed likely to be disturbed and shall be supported at suitable intervals to prevent undue sagging of these cables. So, on the surface of a wall or on the underside of a ceiling or roof, in a space between a floor and the ground to which a person may be given entry. In a ceiling space having an access space exceeding 0.6 meters high. Within 2 meters of any access to any space to which a person may gain entry, and below raised floors. So these are situations where cables are deemed likely to be disturbed. So they need to be supported at suitable intervals to prevent undue sagging. So on the surface of a wall or on the underside of a ceiling or roof. So when you're running it along the surface of a wall or along a ceiling or along a roof or under the roof, and a space between the floor and the ground to which a person may gain entry. So the basement and the ceiling space. So if the ceiling space has an access space exceeding 0.6 meters high, so basically you can crawl around inside it, you need to make sure the cables have adequate support. And within 2 meters of any access to any space, so within 2 meters of the manhole, within 2 meters of the door into the basement, and below any raised floors. So a raised floor, for example, inside of a plant where the floor is raised off the ground. So protection methods, so where protection of a system is required, the wiring system shall be provided with adequate mechanical protection to prevent damage, provided with an earth metallic armoring, screen, covering, or enclosure, or protected by an RCD with a maximum rated operational residual current of 30 milliamps. So an RCD for personal protection. Oh, where wiring systems change direction, bends shall not cause damage or place undue stress on their sheathing, insulation, or terminations. What does this mean? Undue stress. Why are we worried about undue stress on their sheathing, insulation, or termination? And weaken the insulation of the conductor? More heat, yeah. Can break the conductor, yeah. Internal damage, yeah. So everyone's worrying about the conductor. What about the terminations? Loose, yeah. Come out, yeah. So what happens when we tighten down a termination, especially on a circuit breaker, and the cable we've bent into it is under a lot of tension? So cables, the termination points of a circuit breaker, they heat up and cool down over time. And if we've tightened it too much and it shrinks, and then we've put too much tension on, it's more likely to ping out. Yeah, it wants to come out. So it's going to come out. If we make sure the cable is nice and relaxed, it's having a nice, easy, chill time, it's going to want to stay in put. But if we put it under too much stress, it's going to want to gap it. You know, kind of like that partner, you know, if you put them under too much stress, they just want to gap it. You know, I don't know how my missus puts up with me. Anyway, cool. So the bending radius recommended by the cable manufacturer shall be observed. When the information is not available, the good consideration is 6 for unarmored sheath cables. So your normal cables, 6 times the cable diameter is the internal radii. So the internal radii of the bend, or for armored sheath cables, so your steel wire armor, 12 times the cable diameter. This way we ensure that it's a nice smooth bend and it's not going to cause undue stress to the copper sheathing, or in the armored case, the armor. Cool. And supports in contact with cables under pressure from changes in directions shall not have sharp edges. So if we're pulling something tight along the cable tray, making a tight bend along the hard wall, we need to make sure there are no sharp edges, or we put extra mechanical protection in place. Built low voltage track system. So supports for a suspended track system shall be of appropriate design, spaced at intervals of no more than 1.5 meters apart, and arranged so that the system is held securely in position without sagging or undue stress. So suspended track system. So this is track lighting that is suspended from a point in the ceiling. So there's a pole that comes down, and then we have a track light or an LED bar light. Cool. So detrimental effects. So between circuits of an electrical installation operating at different voltages, such as extra low voltage and low voltage. Common enclosure cables. So conductors that form part of different electrical installations shall not be installed within the same wiring enclosure or the same multi-core cable. So what do you think this rule is talking about? Induction. So basically what it's saying is if you have two cables, one from one house and one from another, they should not be installed in the same wiring enclosure or same multi-core cable. This is to make sure that a dead short in one installation does not affect another. So one example is you may have a cable that comes from, say, the second floor of a building down to the first floor. So to ensure that even if that cable is running through the other installation, we must make sure it is in a separate cable enclosure. So the best way to do this, if we have cable tray on level 1 and we've got cable coming down from level 2, we run the entire length of cable coming from level 2 through level 1 in conduit and right on the conduit fed from level 2. We must make sure that we maintain separation, and it sounds bad when I say it, discrimination. Sounds really bad. They're two electrical terms I don't like: separation and discrimination. Segregation, that's another one. But when we're talking about discrimination in terms of the way that protective devices work. We're not talking about discrimination as in racial slurs. Yeah. I love how you brought that out, Timothy, and we go right on to segregation. Yeah, it can be, but we need to make sure it's clearly marked as to what it is and where it's from. Cool. Segregation. So when conductors of different domestic or non-domestic portions of an electrical installation that form part of a multiple electrical installation terminate in a common enclosure, they shall be effectively segregated from each other within that enclosure. Probably every 3 or 4 meters. I just wrote on the conduit with a Sharpie, like a very good permanent marker. Cool. Note: effective segregation may be achieved by the use of independently sheathed cables, barriers, or fire-resisting material, or by distance. So that's how I achieved my segregation: barriers with conduit. Cool. Cables of high voltage circuits and cables of low or extra low voltage circuits shall not be enclosed in the same wiring system. So they may be enclosed in the same wiring system only when one of the following arrangements is employed: for low and extra low, not high and low. Low voltage cables shall be of a type providing the equivalent of double insulation. All cables of each conductor of a multi-core cable shall be insulated for the highest voltage present. The low voltage cables shall be installed in a separate compartment of a common cable trunking system, having fixed and continuous barriers between compartments. So that 2-part trunking that we saw before, we can have one half with power and one half with data. It's not recommended, but it is allowable. Cool. So then we have types of wiring enclosures. So the following types of wiring enclosures may be used for protection of cables requiring further enclosure as specified in clause 3.10.1. So steel conduits or other metal tubing, flexible metal conduit, rigid and flexible insulating conduit, corrugated insulating conduit. So those are what we allowed to use under clause 3.10.1 for separating wiring enclosures. So cable trunking systems to AS/NZS 4296. You can look these up. They are quite boring. Or without compound filing, with or without compound filling. Other wiring enclosures providing mechanical protection at least equivalent to those listed in A and B. Cool. Change of wiring enclosures. Any change from one type of wiring enclosure to another shall be made at a switchboard or by means of a suitable device that provides for the complete protection of the conductor insulation and for continuity of conductive wiring enclosures. So if we're using a steel conduit and we go to plastic, we must make sure that we have continuity of conductive wiring enclosures. So we need to make sure that we run an earth inside of our plastic, which then bonds to our steel conduit. Cool, in direct sunlight, basically making sure that it's a type designed for such use or it is painted with a light colored water-based acrylic paint. So if it is a not UV conduit, we can paint it with a light colored water-based acrylic paint. Trunking. So trunking installations shall comply with the following. Covers shall be able to be opened where practicable. Covers shall be continuous when passing through walls or floors. So we have a piece of trunking that goes through a wall, that cover must be continuous. If it goes through a floor, it must be a continuous cover. The trunking shall be accessible through its entire length. Cables installed in trunking shall not rely on any readily removable covers for support, so we cannot use the cover as a form of support. Non-hygroscopic trunking shall be used to enclose insulated unsheathed conductors. But what does non-hygroscopic mean? Doesn't like water? Yeah. Yeah, so it does not absorb water, whether from water readily accessible or water in the atmosphere. So unsheathed conductors, insulated but unsheathed. So conduit wire. Cool. Live parts of accessories mounted on cable trunking shall be arranged so that basic protection is provided in accordance with 1.5.4. So that's your PowerPoints mounted to the trunking. Cool. Suitability and protection. So cables installed underground shall be provided with suitable warnings, markings, or other means, minimizing risk of inadvertent damage likely to be caused by manual or mechanical excavation work. So making sure we put the danger tape down. Cool. And we talked about the classification of wiring systems. So they're either A, B, or C. So A is inherently suitable for installation below ground and no further mechanical protection. B, suitable for installation below ground with additional mechanical protection provided by the cable or enclosure. C is one in which the wiring system is laid within a channel chased in a rock surface. Underground cables shall be A, type specified in column 1 of 3.4, table 3.4, installed in accordance with the category of installation permitted in columns 2 to 9 of tables 3.5. So either they're a type specified in column 1 or installed to columns 2 to 9 of that table. Category A. So, systems recognized by the standard are the following arrangements. System where cables are enclosed in heavy-duty insulating conduit. A system where cables are enclosed in insulating wire enclosures encased in concrete. System where unsheathed cables are enclosed in galvanized steel pipe without further mechanical protection. No, metal conduits are not suitable for this purpose. A system where armored sheath cables or neutral screen cables are buried direct in the ground without mechanical protection. Cool. So there you go. Category A system there, and then a category B. So category A, Marley power duct system, where no additional mechanical protection is required. Then the Marley power duct system, medium duty, where additional mechanical protection is required. So you've got heavy duty versus medium duty. Cool. So suitable protection cables installed shall be suitable for the environment, provided with protection against inadvertent damage. provided with suitable warnings, markings, or other means to minimize risk. So, minimum depth for low voltage, 600 mil. So that's to the bottom of the trench. The minimum depth of cover is 500, but to get to that, we need to dig down to 600. Minimum depth for high voltage is 1200. We need to use warning tape above underground wiring systems. So 600, buried conduit or cable, cover with sand, another 100 mil, danger tape, fill the rest of the trench. Install in heavy duty ducting conduit. So it is called ducting, but it is a form of conduit. Cool. Some cables are suitable to be installed directly in the ground, but we need to make sure that these cables are designed for this purpose. Have soft bedding of at least 50 mil for cables buried directly underground, i.e. river sand, and 50 mil on top. So dig to 600, 50 mil of sand, chuck cable in, 50 mil of sand, compact, stone 100 mil, danger tape, fill trench. Install a mechanical barrier on top of cable called a MAC slab or mag slab. This will be dependent on the system that you are using. Have route marked on plans, so good practice, GPS points. Warning labels on entry points of buildings. So that's that white danger live cable buried here. We need to install that where the cable enters the building. Long runs, a good practice to install underground enclosures. Again, good practice, not 100% necessary. Does make pulling them through a lot easier. And this is table 3.5. So this determines whether it is a category A, B, C, or whether it is not permitted. So we are not allowed to use insulated unsheathed conductors and heavy duty fiber cement conduit, or fiber cement, or medium duty gal, or buried direct in the concrete, or chased in the rock with no enclosure. So we need to ensure that we use this table if we're doing underground wiring systems. This is where it talks about minimum depth of cover. So 500 for Cat A and B, where there's no surface covering, or less than 75 mil thickness of concrete. Within confines of a building. And elsewhere, it's pretty much the same. The only time it changes is when we're talking about concrete with a 75 mil minimum thickness. That's just more about the size. So insulated aerial conductors, it's a good read. Stop there. For that section, cool. So note these down. I want you guys to read through these on your own time and try and understand them. I want you to read through section 3.10, 3.3.2.8, and 3.9. Cool. So common areas that we normally see with support systems is poor fixing, sharp bends, unsupported spans, and exposure to UV and moisture. 3.3.2.8, sections 3.10, and sections 3.9. Just so there's no doubt what's going on. There you go. Cool. There's one more topic that I want to go over before we finish, but I understand we've been going for quite a while now. So everyone stand up, walk around, 5 minute break, get a drink, go to the bathroom, and I will be back in 5. All right, before we wrap things up, cool. Moisture and fire barrier rating. So, has anyone had to work in fire cells or anywhere that required firewalls? Firewalls, yep. The enemy of the Sparky. Because we want to make holes, but they don't want us to make holes. So, well, so there are a couple of things to worry about when it comes to firewalls. Cool. So if I drill a hole through a fire-rated wall to run a cable, what might happen in the event of a fire? Yep, can track through the hole, path for the fire to travel. Yep, and the best thing is we've provided a path with our cable. Yep, so the fire goes through the wall. So, what must we do now that we've made a hole in the firewall? Fill it in with what? Good. Yeah, that's one way of putting it. We need to fireproof it. What do we use? A fireproof sealant. Yes. Or fire cork. Fire collars. Yep, we can use fire collars and fire putty. Yep. What's the consequence of moisture getting into an IP rated fitting? Damage. Yep. Stops working. It can't drain. Yep. Fitting breaks. Cool. So, for the IP fitting, so here we have our the circuit matrix. I've hidden the pen. Cool. So for imagine this is outside. We have a steel post here, and there's a steel wall. Right. This is on the roof of a building, and we want to install a power point here. What is the best way for us to run our conduit? Where is the best run for our conduit? Okay, one of the best things we can do for this is if we run our conduit, I'm going to use some green. So we run our conduit here. It goes behind the post and carries on. The best solution is we put a junction box here with a bottom entry, and we bring our conduit, our flexible conduit, down and up. The reason we do this is if moisture somehow manages to make its way into the junction box or into the power point, at least there is a chance that the blue water will gather here in the bottom of the conduit first. So we're lessening the possible dangerous side effects of moisture getting in, and at least making it so that the power point's going to last a while. And then some guys will even take their knife, and I know you shouldn't, and they'll cut a little slit down here at the bottom in the flexible conduit so that the water at least has a little bit of a drain. Again, not best practice, but still better than nothing. Cool. So, common ways to maintain tight barrier integrity for firewalls: fire collars, intumescent wraps, grommets, fire-rated foam, vent valves and drainage holes in conduit where permitted for moisture, and avoiding large vertical drops into low enclosures that collect moisture. So we do have a large vertical drop. We want to come down past the enclosure and then come back up. Okay, so I've given you a few ones to look up. Here are some more. So you've got 2.9.7 note 4, fire sealing of switchboard entries. So we must make sure that our entries or any holes into our switchboard are small enough as to not allow the proliferation or spread of fire within an installation. So in domestic, the best way to get around this is to fire foam or fire cork the penetrations into the switchboard. And commercial and industrial, depending on the type of switchboard, if we have a gland plate at the top of our switchboard, we make sure we only drill enough glands for what we're going to use, and they're tight fitting around the cables. And then we've got moisture protection requirements in 3.10 2.3, drainage for condensation, and then Appendix H is about mechanical protection and fire classification codes. So these are all things that you need to be aware of working in the industry. There's always going to be moisture, and in construction, we're going to come across firewalls and fire cells. It's becoming a lot more common in commercial buildings to have firewalls. One of the more interesting jobs I've heard about is a Porsche garage here in Wellington. Basically, they set up a fire cell. If one of their Porsches catch on fire, they just push it into the room and watch it burn. They don't worry about the fact that they can put it out. They just push it into the room, shut the door, and let it burn, because it's going to take 4 hours of continuous water to put that thing out and keep it cool. Just the EV ones. Yeah, just the EV ones. Sorry. Yeah, any EV vehicles. I had an AEG battery catch on fire on site once. We just kicked it into a storm drain and let it burn itself out because we didn't have enough water on site to deal with that. And that is what we're going to cover for today. Give me one moment. Bucket of sand. Yeah, but then the sand might turn to glass. Free window.